Hi, welcome back. This will be a video on setting up input with a pull-up circuit on the Arduino. This will be similar to the GPIO input with high impedance. The largest difference here we can see in the circuit is instead of sourcing 5 volts externally through the switch like we had in the previous video with GPIO input with high impedance, with the pull-up, we're going to pull the pin to ground. So we're going to set our GPIO input pin up. The direction register will be set up to 0 for input, but we'll set the output port pin for this pin to a high or a 1 to engage the pull-up circuit inside the Arduino or the ATmega328 to source 5 volts internally to the pin, driving the pin high while the external switch is open. When the external switch is closed, that voltage will be pulled to the external ground, pulling the pin low. So in this case, we're going to have the opposite. Our pin will be high while our external switch is open. So we will detect input when the pin goes low. All right, so I just have a little bit to modify in the external circuit. I'm going to disconnect my Arduino from my computer. And then I just have some slight changes to make in the way the circuit is run. Right now, we have our circuit for the push button is set right now to where we have 5 volts on this red wire coming from the external 5 volts of the Arduino into one terminal of our switch, which I have as terminal 17. And then the other terminal is going to the orange wire on terminal 15, which is going to my input pin. We also have a pull-down resistor in terminal 15 to ground. And if we notice in our electrical circuit, we're not going to need that anymore. So the first thing I'm going to do is remove this 1K ohm resistor that was being used as a pull-down. And I'm going to remove the 5 volt source wire from the circuit. And I can remove that from the other side of the Arduino where it was going into the 5 volt source. I'll leave the input pin where it's at. But now I'm going to want on the other terminal, so the input pin is still on terminal 15 going into one pole of the switch. On the other side, I'm going to want to connect this to ground. Now I can just use a simple wire for that. So I'm just going to hook a new wire in terminal 17. And I'm just using a black wire just to signify ground. And I can put that into the ground rail anywhere. And so now when I push my button, I will pull voltage that's on the orange wire through the switch to the ground rail. And then this ground here is going back to my board, which I'm going to disconnect from the board so that it's not connected when I'm programming. Nothing else in the circuit needs to change. So I still have my orange wire going into pin 8 or port B pin 0 for my input, going into my switch. My switch is then connected to the ground rail by this black wire. My green wire is still connected into pin 7 or port D pin 7, and that's connecting to my LED on the anode side or positive side. The negative side of the LED is connected to this 220 ohm resistor, which is going into the ground rail. And then I have my common ground wire in the ground rail that I will connect to the ground pin on this side of the Arduino. So my circuit is all set up. Now I just need to make some slight changes to the programming. So looking back, I'm going to copy this to a new project so I can keep this one set for high impedance. So the very first thing I'm going to do is I'm going to copy all of this code. And then I'm going to close this solution. And then I'm going to start a new project. And once again, this will be assembly, and I'm going to call this GPIO Input Pull Up. And that's in my projects directory. And this will be on the ATmega328. And then I am going to replace all of these lines with the code I copied. All right, so once again, we are still setting port B up as input, but instead of high impedance, we need to set the port register to a 1 to engage the internal pull-up circuit, the source voltage inside the pin. So we, instead of an CDI to clear the port register, we want an SPI to set it high to make B0 pull up. Our output pin is still going to be on D7, so we're doing an SPI to set D7 to output, and we still are clearing our LED off to start with. Our scan is just going to work the exact opposite. So if the pin is high, we want to clear PD7 to turn the LED off, because if the pin is high, that means the switch is open and we're not receiving input. When the pin gets pulled low, then we're receiving input from the user. So we will skip clearing this if the pin is high. So, I'm sorry, if the pin is high, we want to clear this. So we will skip this if the pin is cleared. So if the pin is cleared, we'll skip this. So it's the exact opposite of the high level pseudocode. And then here, if the pin is high, we want to skip setting the pin high. So we could rewrite this to say if the pin is low, we have received input, so we want to skip turning LED off. Otherwise, we're going to clear it off. And then if the pin is high, skip turning the LED on. And then this would So that's maybe a better way to write it. So if the pin is low, we're going to skip turning the LED off. If the pin is high, we'll skip turning the LED on. So it's just the opposite condition of what we had before. So I'm going to keep this one short. I'm going to build the solution. All right, we had a successful build. I've got my ground wire is disconnected. I'm going to connect my Arduino. To my computer. And then going to I should check to make sure that it came up on the same port. And I see it on COM6. So now I can program it using my COM6 programmer for AVR Dude. All right, I don't see any errors, and it said it finished. So now I can plug my ground wire into the Arduino ground. So right here, the Arduino ground. Now if I push my switch, we get the light to light up again, because right now the internal pin should be high because I've engaged the pull-up circuit on the orange wire going into pin B0. If I push the switch, we're allowing that current to flow out of the pin through the switch to ground, pulling the internal pin in the ATmega chip low. And we're detecting that and turning on our LED. So the circuit is pretty much the same, only now we have an external ground instead of an external voltage source that we were getting from the 5-volt external voltage of the board. So that is GPIO with pull-up.